Greetings, YouTube. When I ordered the wedding ring that my wife and I have, I shall show you mine right here. I ordered rings that are made from titanium and silver. The gray metal you're seeing here is titanium. The bright shiny silver in the middle is in fact silver. I chose them for a number of reasons. One, I'm a big fan of silver. You'll notice everything I'm wearing is silver. Um, I like titanium. It's a great metal. It's light, strong, very durable. But there was another reason. It wasn't just aesthetics. It wasn't just my personal likes and dislikes when it comes to metallurgy. That was a factor. It is the fact that my wife is really, really hard on every single item that she has ever laid her hands on. She is, in effect, a walking stress test for everything that we own. And she has been successful at breaking things that I thought people couldn't break. So, I ordered rings that I figured she couldn't damage. Now, her ring is the same design as mine, but hers is narrower. This is a 10mm wide ring. Hers is only a 6mm wide ring. And this ring doesn't even fit on my ring finger any longer because I lost so much weight. Nor does hers, because she lost so much weight. So now we wear them on our middle fingers. And it's been quite successful. And you may be asking, why is he talking about his wedding rings? Well, I'm talking about my wedding rings because sometimes the best test of something, the best gauge of its quality, is how well it stands up to rigorous wear, to a stress test. And just like wedding rings, one of the things that stands up, or at least should, to solid, hard use is a scientific theory. Because that's how science really works. It's a stress test. Someone presents a concept, and they say, here is my idea. And they do this through collecting data, drawing conclusions, and publishing their findings in peer-reviewed journals. And they're called peer-reviewed journals because the peers of that researcher are going to review the material and test it themselves. They're going to take that data into their own labs, they're going to try to replicate it, and they're going to try to see if it stands up to the test of time, to the stress of that testing. And if it does, and if it does it rigorously, then that new theory is adopted by the community at large if it's a better version of an old theory, one that does not stand up to the test of time as well. For example, at one time, we thought that there was a substance known as ethereal fluid that explained the transmission of heat from a warm object to a cold object. So if you had two objects next to each other, one was warmer than the other, eventually they would become the same temperature. And scientists said it was because there was a fluid flowing between the two objects. Of course, over time, we realized there is no such fluid, that heat is another form of electromagnetic radiation, and it can be explained by infrared heat transfer through waves. There is no material, it does not need a medium to flow through, it will function as readily in a vacuum as it will in our atmosphere. But that old theory was around for quite a while because no one had come up with a better explanation. And when they did, they took it out, kicked it around, discovered that, hey, this new theory is a whole lot better than the old theory. It's simpler, it's more elegant, doesn't require the existence of a fluid that we can't detect in any way. So let's try this new theory out and see how it works. It works really well, and we've been using it ever since. But there are still textbooks out in the world, if you want to dig around far and long enough and hard enough, that will have this theory in them, because the books are time capsules of old research. I'm going to link into something someone else has said about this topic, specifically that science writers often fail to convey to the reader, the general public at large, that this is how science works. It works based on disagreement. Scientists come together, they lock horns, they try things out, and that's how science works. It's a process of whittling away Everything that doesn't work and what you have left is what does. And there are some researchers that believe that there are underlying theories that we have yet to discover, a potential theory of everything, referred to as a TOE, that will help us to understand things to even a greater depth. Just as we were able to link the electromagnetic forces together, hopefully someday we'll be able to link all natural forces together into one theory. A step in that direction has been string theory, or its more proper name, membrane theory, or M theory. And again, that's trying to find out the very nature of the universe itself, the very fabric of reality. And you do it by presenting things, seeing if they stand up to the rigors of tests and time and stress, and if they do, you adopt them. And in that process, there's a lot of contention, there's a lot of arguing, there's a lot of fighting and disagreement. And that is how science functions. And I think it disturbs a lot of the general public because for some reason, a lot of people have the impression that science is about making declarations that never alter. That this here, right now, is the very foundation of reality, and it shall never alter from this point forward. And that isn't how science works. That's called dogma. And that's how a lot of dogmatic faiths function. They say, this is how the world is, it will never change, it has never changed, it never will change. That's not science. That's not how science works. That's not how human beings acquire knowledge. It may be a way to understand certain things in life, but not scientific things. So I think it's important to remember how science actually works, as opposed to the way some people think science works. So, the next time someone banties about some questioning of scientific theory, make sure that they're actually questioning scientific theory, the scientific method itself, and they aren't just trying to put forward a personal worldview and hoping that people will buy their opinion as scientific fact.